Hello viewers and my dear students. Welcome to session 3 on analysis of axisymmetric solids. We are giving a demo on analysis of a closed cylinder under pressure using Ansys Release 14. I have already started this. In the first session, I totally concentrated on theoretical part, how to do this hoop stresses theoretically here. Okay, that means theoretical that is theoretical determination of hoop stresses on the inner fiber, outer fiber, and all that I've done. And the same thing have to be verified here. In the second session, I've already started with the modeling part of it. Okay, now we'll continue with the modeling part here. See here, this was the thing here. Now, see here, this and all that we know that this is axis symmetric. One half I have done it. Okay, one half I have done it. Okay, and in fact, in the last session, this is the axis of symmetry. Correct? No, this is the axis of symmetry, and this is 0, 0. This is 50, 0. This is 240, 0. This is 0, 240. This is 0, 220. This is 34, 220. This is 34, 20. This is 0, 20. Correct? No? 0, 20. This is 0, 0. That means I have got all the key points here. And you please look to the previous session. I got the key points. And using the key points directly, that is, I have created areas arbitrarily. Okay. Areas arbitrarily. Okay. I have created areas. Create areas arbitrarily through key points. Through key points, I clicked on 1, 2, 3, 4, 5, 6, 7, and 8, and then 1. If you do that, you have got the areas. Okay, in fact, in the last session, I had even meshed it. Okay, I had even meshed it, and after meshing here, I had even applied the boundary condition here, symmetric boundary condition here, because one half of the cylinder under pressure is here, another half is here, and as you know here, this is subjected to internal pressure. That means here you have a pressure of 1 MPa, here also you have a pressure of 1 MPa, here also you have a pressure of 1 MPa. Correct? No? That means this, because of this, once you have a pressure here, this diameter is going to increase in this fiber, that is inner diameter. Okay, the inner diameter is going to increase. As a result, the inner diameter is going to increase and it will result in hoop stresses, that is tangential stresses are. Okay, that has to be determined. Even here, because of the pressure, even this, even here also, the diameter is going to increase depending on the thickness, and as a result, the hoop stresses will be developed on the outer fiber also. Okay, these things I have told you already in the first two sessions. Okay, please follow. These things I have already told you. Now you see here. There I told you save and resume option. No, in that way actually I had done the symmetric boundary condition. I had applied even this what exactly is that is pressure 1 MPa here, 1 MPa here, 1 MPa here, and I was about to solve that also. At that time the session ended. Now I'll repeat that procedure only for the benefit of the students. See here what I'll do is I'll go for meshing now. Meshing is mesh attributes, no? Default attributes only set, because there are no multiple elements. You don't have to attribute different properties for different elements. There is only one material one. Okay, this plane 182 is the element chosen, and material number is 1 only. That is why you just mesh attributes, default attributes only you take. Then the important thing is the size controls. See here, size controls here. You manual size, you can do it in any way. See here, if I take lines, no lines. Picket lines, okay, picket lines. I can pick any line here, okay, pick it any lines here, and I can say okay. Then number of element divisions here, 10 means here, that line will become 10 elements. Okay, can you understand? See here, line, manual size, lines, picket lines. If I take this, I can choose this line and make it as 5 elements. I can choose this, make it as 2 elements. I can take this, make it as 5 elements. This has 20 elements, anything I can make. Okay, these things you have already done it, you know the procedure. Now what I do here is manual size, lines, picket lines, I don't take. all lines I'll take. Okay, pick it lines means every line I have to pick and assign the number of elements or assign the number of divisions and all that. Instead, what I'll do, you carefully observe. What I'll do, manual size lines, all lines I'll go. All lines means it applies to all the lines. That is this line, 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 this line. In that way, it applies all the lines. Here, number of divisions 2 if I give number 5 divisions means for this also 5, this also 5, this also 5 it gives. That's why number of divisions giving is a waste here. Because if I give number of divisions 5, this is also a line, this is also a line. This also divided into 5, this big line also divided into 5. In small line also divided into 5, this small line also divided into 5. If I say number of divisions 10, this also 10, this also 10, even this also 10, that means this has no regularity here. That means we'll have it a systematic way of doing here. Now, if I do element edge length as, see here 2, let us say. If I do element edge length as 2, this you know here, how many this thing it is there? It is 50 mm, correct? No? In 50 mm, element edge length is 50 means 50 by 2 means 25 elements are created here. Can you follow? And the element edge length 2 for this line, for all lines, no. Here automatically it is 20. 20 means in this itself you are getting 20 by 2, 10 elements created here. If it is 240 here, 240 by 2 means 120 elements are created. This becomes more systematic. That is why now instead of taking number of elements divisions, understand this properly. Element edge length you take. Element edge length if you take, that means in this line, this has a total length of 50. One element edge length will be 2 mm means totally it is 50 means 25 elements are created here. It will be logical. Even 240 here, element edge length 2 means 240 is the total length, 120 elements are created here. Even 20 means 20 by 2, 10 elements are created. In that way, it has some meaning here. Okay, even here it is 34 means 17 elements are created. In that way, I'll take element edge length as 2 for all the lines here. That is, depending on the length, element edge length will be 2. That means here, as I said, 25 elements are created. Here, 10 elements are created. In this, it is 240 means 120 elements are created in that way. Okay, element edge length 2 you remember for doing this problem. Say okay. Okay, then you go, once you element edge length has been given, okay, 2, then you go mesh, areas, free you do, okay, then pick this area. Just say okay. It takes time, you have to wait because so many elements are created. In that way, you see here, so many elements, 25 elements you get here. And if you go here, almost 240 by 2, 120 elements you can find. Actually, you can count exactly 120 elements will be there. And a more proper way of doing this. Okay, more number of elements, more correct will be the answer. Okay, and particularly hoop stresses, verification and all that is very important to us. And we'll just see. Now, as you know here, after meshing, we'll go for loading. Loads you take. Okay, loads you take. Define loads. Apply. Structural you take. Displacement you take. Symmetric boundary condition you take. Okay, symmetric boundary condition. On lines you take. This and this, the axis of symmetry. Okay, on the other side, on the left side, you have a symmetrical, this type of portion. That is why this is the axis of symmetry. This is the axis of symmetry. If you just say, okay, you have got this. Now, if you look here, you can create yes, yes, yes and all that would have been created here. You can enlarge and see yes, yes, yes means here also you get yes, yes, yes and all that. It is axis of symmetry. That is, the symmetry boundary conditions have been applied to this line and this line. Now you see here, we will apply pressure. Pressure on lines you take. We will apply pressure here, and pressure here. Okay, and say okay. And say here, this is 1 MPa is the pressure, 1 Newton per millimeter square. See here, be careful, all are modeled it in mm only. Don't put it in any other unit. 1 E6 and all that don't put. It is 1 MPa, but it is 1 Newton per meter square. But now what I want is 1 Newton per millimeter square. That is why it is 1 only. You put 1 only here, 1 Newton per millimeter square, that is 1 MPa. Okay, and don't put 1e6 and all that. Okay, be careful. If 1e6 means it is 1 into e6, that is 10 to the power of 6 Newton per meter square. But what I want is Newton per millimeter square, that is 1 is enough. Just say okay. See here, I have got the pressure load here, pressure load here, pressure load here. Once everything is done, okay, carefully you see, solution, solve, current LS you do. It takes time, I'm telling you, okay, because it is final mesh, it takes time, it will solve. Okay, solution is done. This you must get. If you have done carefully, you see here, if you don't get this here, okay, you increase the number of elements. Okay, if the meshing is proper and all that, in case you don't get, increase number of elements, you get it. But now this element is done 2 mm is good enough, and I got the solution is done. That means you are getting the answers properly. You don't have to worry. Okay, close this also. Okay, now the answer is that. Now we have to find for the post processing. Now the solution phase is over. Now I'll go for general post processing. General post processing I'll go. Now very important you see here. First we'll see what exactly are the results. Okay, plot results, deformed shape, deformed and undeformed if shape. Say okay. Okay, this is how it has deformed. This immediately, this is an examiner, this for maximum deformation here in this, when it is subjected to internal pressure, the maximum deformation is 0.001285. You can actually find, okay, where exactly is the maximum deformation, but this is an answer for the exam. Naturally see here, since you have everything you have modeled in Newton, millimeter and all that, this maximum deformation what you got, you should read it in millimeter only. 0.001285 millimeter is the thing, is the answer, is one of the answers. What you do, okay, this immediately plot controls, write meta files, invert white and black. Okay, in that way you store it in this paint file. Okay, you store it in a paint file. This black will become white. This is the thing. Okay, one plot you already got. Plot elements you'll go. Then again you see here contour plot you go. Nodal solution you go. Okay, very important is this. Okay, DOF solution, that is just now we have got this vector displacement this thing. No, this don't worry. Okay, this stress you go. Stress I've told you in this is X, this is Y, tangential to this is Z. Okay, tangential perpendicular to this is Z. That means Y will be axial stress plot. Okay, Y will be, that is Y is this, Y will be axial, that is axial stress plot. Z which is tangent, which is perpendicular to this plane is the hoop stress plot. In that way you take this Z component of stress, this you say okay, this is a perfect way. If you see here, this maximum here is getting 2.72. You see the theoretical one also. Okay, exactly this is what you got, 2.72, and outer also this we'll draw a graph along this in the next session. Okay, and we'll verify exactly you got the answer what you got theoretically. And as you see here, 2.72 MPa is the stresses developed at the inner fiber. At the outer fiber also, this color if you see somewhere 1.72 and all that, that also is proper. This also immediately plot controls. Okay, and write meta file, invert white and black. In that way you get this. This is another plot what you get it in paint. This is also for the examiner or record purpose and all that. This is another meta file plot you have to do. Then plot next is contour plot, nodal solution. Then Y component of stress you do. This is axial stress plot. This is also another plot. What you have to know, this maximum axial stress is 4.33. That means which is increasing the length of the closed vessel. That is, this is closed vessel under pressure, the closed cylinder under pressure. When it is subjected to pressure here, P, the length is going to increase and the maximum pressure is 4.33 MPa. Now I have shown you the different plots. The other features and all that I'll explain in the next session. Thank you friends. Thank you very much for watching. Now we have come to the end of session 3. In session 4, I'll show you more features of this. Thank you.